Hi, somebody came by and asked me this question to find the derivative of a product rule, including the chain portion of it, and it's in radical form as well. So I wanted to work on this problem for you. There's a lot of algebraic manipulation, so you better be very, very careful when you're doing the algebraic manipulation. We're going to first call this f right over here. We're going to call this g right here. And we're going to change f into its from radical form to exponential form, which is equal to negative 4x cubed minus 5 to the 1/4 power. Notice that the index becomes a denominator on the exponent right over there. So f prime, using the power rule, bring it on down, 1/4 times negative 4x cubed minus 5. 1/4 minus 1, as you subtract 1, it's going to be negative 3/4. And then that times the chain portion of this. Negative 4x cubed, using the chain rule, we bring it on down. It could be negative 12x squared. And then times the derivative constant, which is 0. I'm going to clean this up really nice and neat and take care of this negative on the exponent as well. So you have to be very careful on the exponent. F prime, in other words, if this goes to the numerator, it's like over 1. Negative 12x squared all over 4 times, we're going to change it to exponential, from exponential to radical form. It's going to be the 4th root of the quantity negative 4x cubed minus 5 cubed, the inside. And that's going exponential form into radical form by its very definition. Cancel these out, becomes a 3 right there. Becomes negative 3 x squared all over the 4th root of negative 4x cubed minus 5 to the 3rd power. Okay, so there it is right over there. G prime is equal to just negative 3. The derivative of negative 3x is negative 3. The derivative constant is 0. You should know that by now, right? So y prime, which is equal to dy over dx, is equal to f prime times g plus g prime times f. If we're using the quotient rule, y prime would equal f prime times g minus g prime times f all over g squared, where y is equal to f over g. So I like to use I created this equation when I was in high school by myself, and I couldn't remember the product rule and the quotient rule very well. So if I memorize the product rule this way, then the quotient rule just becomes minus and then over g squared. So it was a cute little way for me to memorize the product rule and the quotient rule at the same time without getting too flustered. Way back when. So using this equation right here, y prime, so f prime is negative 3x squared over the 4th root of negative 4x cubed minus 5 to the 3rd power. That times g, which is right over here, there, negative 3x minus 5, plus g prime, which is negative 3, times f, which is right there, 4th root of negative 4x cubed minus 5. There it is. What happens is this now, you have two basic terms because of this positive plus right there. So you have this first term right here and the second term right here. What you want to kind of do is, since you have a fraction on part of the first term, what you want to do is you want to multiply top and bottom by the 4th root of negative 4x cubed minus 5 to the 3rd power, multiplied by the numerator as well, negative 4x cubed minus 5 to the 3rd power. And you kind of should remember some part of this as well because of the fact that, sorry about that, kind of remember some part of this because of the fact that you want to try to get common denominators if you can't get into single fraction. So y prime is equal to, I'm going to factor out a negative 3x plus 5. Negative and the negative cancel. You're going to end up with 3 3 times 3 is, excuse me, 9x. Looks like I'm making a little bit of a mistake somewhere. It's x squared, it's x squared, it's x squared right here. Sorry about that. So 9x squared right over here times 3, so negative 3 x squared times 3x is going to be 9x cubed, and then distribute the 3x squared plus a 5, end up with plus 15x squared. On the second portion right here, you notice that when you multiply this out, you get something a little bit more different, which becomes the fourth root of negative 4x cubed minus 5 to the fourth power. When you have a fourth power, what literally happens, the solution manual is wrong, by the way, okay, on this one. When you cancel this out, that becomes the absolute value of negative 4x cubed minus 5. You have to put the absolute value when the index is an even power. So the answer in, that the teacher gave you was actually wrong on this. And then I'm going to multiply by negative 3, so it should be minus 3 times the absolute value of negative 4x cubed minus 5 all over the fourth root of negative 4x cubed minus 5, and that whole quantity cubed. That should be the answer. What happened is the teacher decided that that's not going to be the absolute value. We already are assuming that this is going to be a positive portion. Then we're going to go a little bit differently, which is 9x cubed minus or plus 15x squared plus 12x cubed plus 15 all over whatever that was. Add like terms, 9 plus 12 is 27? No. There's something. 21. Yes. 21x cubed plus 15x squared, and then plus 15. Factoring out a 3, 7x cubed plus 5x squared plus 5. Let me see if that was the answer that I kind of got. I'm looking at my answer right there. Yeah, it seems like that was the correct answer. So this actually should have turned out to be 3 parentheses 7x cubed plus 5x squared plus 5 all over the fourth root of negative 4x cubed minus 5 to the third power. So you should find an answer, but this is the one that's supposed to be more correct. So whether they use this one or this one, this is the more correct answer. Anyways, good luck with the homework.